One of these days I'll figure out the volume control. How y'all doing today? Fine. How are you all doing today? Come on. All right. That's a little better. My name is Spencer. I'm here to talk to you today about a little bit of my growth over my career for the last 10 years. This talk is the culmination of a lot of experience, I think both good and bad. And I really appreciate you coming to it, especially a little bit past your all's bedtime, since usually we quit work at 5, right? This talk was a real labor of love, so I appreciate you being here, and I hope you enjoy it as much as I enjoyed putting it together. First things first, I always say this, but before the conversation doesn't end just because I walk off the stage. I'll be here for the next couple of days. If you have any questions about my experience, you can also find me on Twitter at Schneidenbach, where I tweeted out some links to some parts of this talk, which I think are really cool. This talk is really about this company here. It's called Rivet. And what Rivet is a startup that focuses on building integration software for the construction vertical. So this is the talk about for the last 5 years how Rivet has come to be from start to beginning. And when I say there were 3 rewrites, there really were 3 rewrites. And these are kind of what the rewrites looked like. It started off as a project, rewrite to a product, to a software as a service, to a platform as a service. And we are going to talk about all of the steps in between. But Rivet wasn't the only thing that was rewritten. There was also me. Again, Spencer. I know that sounds really corny. I hope it sounded just as corny as I thought it did, that I was rewritten as much as the software was. But this is really about a very personal story about my journey so far. And this is just the beginning, right? But you know, I've been here at NDC Oslo for the last few years, and I didn't always look this good with the nice blue on green contrast. Before I was kind of washed out and a little washed up. This is a picture of me from a few years ago. I look a little different. I think I'm 30 or 40 pounds heavier too. And so I wanted to talk about, because this talk is just as much about Rivet as it is about myself, I wanted to talk about my humble beginnings as a person who worked at a company that I will call JC. So I started at JC October 2009, and it really, how I got the job was kind of an accident. I didn't start out as a developer. I started out as a support person. So I was the person who called when the printer broke, or email wasn't working, or my computer died. That was my favorite one, especially troubleshooting 1,000 miles away. And I wish I could say that I looked as cool as this, you know, plugging Ethernet wires in and out of switches and doing all that. And when in reality, I look more like this. This is a real picture of me from college. You'll notice the mustard. I don't know what that's doing there for. And I don't know why this picture was taken, but I found it on my Facebook. I thought it was pretty funny. It kind of represented how I looked. I had to wear a headset as part of my job, after all. And this was the makeup of the IT department at JC. So we started out, we had the IT manager, the developer who was a contractor with the company. The product that they had was kind of in maintenance mode at the time. And then they had a support person. Well, they didn't really have a support person. They kind of had a support person. They had a support person of the person who knew the most about computers in the company, who was one of the owners of the company. That's right, the president of the company was taking help desk calls when the IT manager wasn't available because he was putting out fires everywhere for the product, or doing something special, doing something special that he had to because he didn't have a program for a certain business process. We had the owner doing our technical support, which is kind of a funny thing. So one day I got a call and he said, "Hey, Spencer, don't you know something about computers?" And I said, "Yeah, I think so." And at the time, I had gotten a referral from somebody who, I didn't want to disappoint, and they said, "Well, they told me that you know something about computers." And I said, "Yeah." And he said, "I'd like to offer you this temporary job, inventorying computers." And I said, "No." And he said, "Well, hold on a minute." And he had a 10-question quiz that he said, "No, you should take this job." So I did. So I did this small side job and eventually was hired on full-time as their support person. I also did their social media for a while. That's another show. And as a support person, I got to work with some really exciting technologies. I worked with Windows XP. A lot of the 150 computers out in the field had all Windows XP. And they had special software to lock down internet or virus protection, whatnot. I also had to eventually learn Active Directory and learned how to manage Windows Server 2003. And then, of course, my favorite, one of the boy, this was just a moment in my career, learning about Exchange 2003. How many people started out as a support person, not a developer? How many people in the audience? Few? All right, cool. There was a few of you. So I came to find out this was not a common thing to come from this, but I dove right in. I didn't know anything about development at this point, and I did my best to learn as much as I could. I thought I was going to be a Microsoft certified professional and pass all the exams and do all those cool things, and I was just learning as much as I could about Active Directory and servers and Exchange management, things that I wouldn't want to do anymore. And one day I asked my boss, who was the IT director, I said, hey, I have a question. This development stuff, I see Keith doing it. Keith is the name of the contractor. And I'm kind of interested in doing that. I took a class on VB.NET in college. I got a C+ in it, so how hard can it be, right? And he's like looking, and think about the IT manager at that point who's making that decision. I was making maybe 10, 12 bucks an hour or something like that. The contractor was being paid 100 or something, and he's looking at that and he's thinking, wow, if I could teach this guy how to develop, I could save an awful lot of money. So it was pretty quick. Okay, why not? What harm's it gonna do? He's gonna, if I fail, then that's fine. I just go back to support. If I succeed, then I do development, and it's awesome, right? So I found some classes online and started taking more classes on programming. And the product was built in VB.NET, and you might think that, well, of course, naturally, that would be your first language. But was it VB.NET? It actually wasn't. It was not VB.NET. Was it .NET Shop? Was it C#? No, it wasn't C#. Was it even something close? Was it JavaScript or HTML or something? No, my first language was SQL. So I learned T-SQL as my first language. So we signed up for classes, and I went to this class by a very good gentleman. I took their 2-3 SQL courses, went through them all, and at the end of it, I was like a SQL master, and I thought I was this cool. I was like fast. I was moving fast. I was updating databases, doing select statements. In reality, looking back, I was more like this guy. So my IT director at the time said, I've got some rules, so I'm going to give you prod access because everything shares the same system admin password, which is great practice, I'm sure. And so we have some rules for playing around in prod. He really instilled in me these rules, like if you're going to do something, that's fine. Don't delete anything unless you back it up first. Don't change anything unless you back it up first. So don't even insert anything. And it was so bad that we had the same... it wasn't consistent across tables, but we had deleted flags on everything, and that was the preferred way to do it, of course. That made sense. So this instilled in me this huge data paranoia almost to make sure everything was in order before I commit transaction or do anything like that. This becomes important. And as Arnold Schwarzenegger said, I'll be back. Or I'd really just hold on to that thought. I'm going to come back to that in a little bit. It really influenced how Rivet was built. So SQL was my first language. Well, naturally, it was a VB.NET web forms application. How many people had done web forms? Awesome. How many people still do web forms? I love asking this question. Do you know why? Because inevitably, people will kind of raise their hand because they don't want to admit it, and they kind of turn away, and they're just a little embarrassed. But I still occasionally do web forms just as part of the job, right? Web forms, VB.NET, thank God they had option strict on, right? At least they had that. So this was kind of the network, the system of applications that we had. We had the ASP.NET Web Forms application, we had a SQL Server database, and then we had this account management software written in VB6, which thankfully I didn't have to touch, although I did have to touch occasionally. Didn't have to touch it all that much. And it was a product that was planned on being phased out at some point anyways. And then we had batch processes on top of the database. How many people have worked on systems like this? This is really common. This is a really common architecture, right? This is just simple, right? And it worked. It worked for that company. They weren't going to grow much past this, so it works, So again, I took those lessons that I'd learned the first time. I learned as much as I could about Active Directory and Server 2003 and all that stuff, and I started reapplying that. I started reapplying that learning and started reading and reading and reading. I'm not a morning person by typical. I'm just not typically a morning person, and I take just as long to get acclimated at work. So what I do is I'd go into work, and before I start tasks for the day, I'd fire up Reddit, I'd fire up Hacker News or something, and I'd read for 30 minutes every day and just get warmed up. And then I'd take the first task off my desk and do it, That's just the way I did things, and this really helped me. So at some point, I became the support person and the junior dev. And that worked well for a while until they decided, you know what, he's pumping out code faster than the contractor is, right? So that was good. I'd kind of quote unquote proven myself. So I moved on. They actually cut ties with the contracting company, and I became the developer, the main developer on the application. And at some point we hired a support guy. Remember that face? He'll come in a little later too. So we hired a support guy to take the job. So this was the new structure. I was making more money. I was writing a lot of code. I was delivering lots of value. And in short, I was doing this. I was making magic happen. It was awesome. I was feeling really at the top of my game. I was what I call a get stuff done engineer. We call it something else in my work, but for the sake of this audience, we'll say get stuff done, right? So I was getting lots of stuff done. I was writing code quickly. I was writing code with actually pretty decent quality too. I was reading not only about how to do certain things in web forms, but like code quality. And I had no mentor above me. The contractor before me, his idea of being a senior developer and writing good code was writing VB6 code, but just writing it in VB.NET. And he was working on Access apps too. So it wasn't doing me any good. So I was really trying to make up for that lack of mentorship by learning as much as I could. And I was getting a lot of stuff done. So one day, a couple years before the end of my time there, I have a little story to tell, right? So they came to me and they said, hey, well, it's a business, right? And businesses evolved. Our target market really used their cell phones. They really used text messaging. So they said, hey, we have to change how we do things. We were doing things this way before. We were using email for a lot of our marketing, but we need to use texting. And the way they looked at me and they said, well, you got to be the one to do it. And they were looking at me like this girl would look at me and just like, you don't have a choice. You're the lead developer at this time. Lead developer, whatever that means. So naturally, we decided to add texting to our application. So we had to be able to send and receive text messages using a mobile phone or the web, and we had to have real-time push notifications. If a salesperson got a text message, we needed to be able to route it right to them. But they couldn't use their real cell phones. There was some turnover. I mean, there was a whole lot of problems like why we didn't want to use the real cell phones, right? If they'd taken a day off or they quit, we wanted to move those text messages on, preserve that history, and do something else. And I was like, what am I supposed to do? Like, I can't just invent this out of nowhere. And then I came and I said, oh, I know. Why not? I've been doing years of reading at this point. I've been reading every single day. I've been perfecting my craft, or honing it at least, not perfecting it by far, but honing my craft day after day. And at the time, there was an exciting new technology coming out called Xamarin. And I read all about Xamarin, and I had read all about lots of other things that I ended up implementing for this company. I learned about Xamarin, and I was like, okay, real time, where have I heard real time before? Oh, that's right, I've heard of SignalR. So SignalR does real time. It's a communication thing, so I can glue them together. I still didn't know exactly how that architecture would look, but put it all together, and it turned out pretty well. So the requirements of this were that I had to be decoupled from the main app for rapid iterative release. Releases were a pain. That's a different story. But I needed to be able to build it and deploy it quickly so that I could, keep developing on my app. And if the main app went down, make sure that it got the message later. And then, of course, we had to have the instant push notifications to the employees. The text messages had to go to the employees. The employees had to respond, send the text immediately back, that kind of thing. So I came up with a really, rough diagram, right? And I said, okay, the customer phone somehow text messages us, and it gets to our app backend. I'm skipping a lot of steps in this picture, right? Like there's something in between. They're not sending text messages to us. But it's getting to our app backend. It's being distributed out to all the sales folks, and it's going, of course, to our database. So I had read about this thing called a message queue, and I was like, perfect, this seems appropriate. Like I could make it so that the applications talk to each other in HTTP on localhost. That seemed like a bad idea. For some reason, it seemed like a bad idea. I couldn't articulate why, it just did. But I had read enough about message queues to know that this is probably a technology, a time that I was, that this particular piece of this particular thing could be used appropriately. And I was really kind of digging the pub sub model, right? Like I just want to, if a text message comes in, broadcast that out. We actually had a few processes that listened for that message. And and at the time, I couldn't articulate it, but I was like, I can't just make this thing like make HTTP calls to all these things in order to move the data around. It's got to be decoupled in some way. Now, I would never have said that then, but I can say it now. I can finally put words. I found my words. I'm like a 3-year-old. I found my words. Well, I wanted to make sure it was decoupled. And so what I ended up doing was using Twilio, great product for text messaging, and then for the app backend and the sales app, the sales app and the devices that were being used, or the sales app that was used for the main telemarketing function, I used RabbitMQ, and I said, awesome, I'll just publish a text message received, and something downstream will handle it. The app backend will do some logic, and then it'll send it on to the sales app, so that way the message is moved appropriate. And it worked really well. And this is kind of how it looked, right? It was kind of coupled together, just functionally, but it wasn't actually coupled. Now, this and the deployment and all of that, what I had done then, which I thought was really cool looking back today, is I had accidentally written a sort of microservice. So that was kind of a cool realization that maybe I knew what I was talking about then, maybe a little bit, but a lot of times not. And that was really one of the lessons learned, right? So we're going to talk about retrospectives, lessons learned. It's really important to me. Learn something new every day. Now, at the time, I could articulate everything that I learned new every day. So this doesn't necessarily go on. Sometimes you're just going to do routine stuff. So learn something new every week. But you know what? I'm not going to apply a time to it. It just is not something that just be a consistent learner. Learn every so often, right? It doesn't have to be every day, every week. Do what's best for you, right? But learn something. Try to keep learning. Try to keep growing. That was a big lesson, big takeaway for me. And this, of course, was the architecture that we were left with, and which was good. And of course, I was still reading. I was still learning. So we applied a little bit of Angular and used that to kind of improve the ASP.NET Web Forms app. And that worked really well for a while. You'll notice that account management is kind of faded away. It's because we were phasing out that product. We moved a lot of that product over to the web application. Thank God I didn't want to do VB6 as much as I'm sure some people loved it, but I was really loving .NET, and I found it disjointed almost. So that was being phased out. It was good. But then something that I really pushed for, the Xamarin Employee app, that ended up getting phased out too, because they were like, well, we can't make the investment in mobile and all these different things. We're putting a lot of weight on Spencer in terms of if he falls into a sinkhole tomorrow, what are we going to do? Find somebody who knows Angular, Web Forms, Xamarin, and they said nobody's using it anyway, so we're going to phase it out, which was fine. And so the retrospective, again, what fit, what didn't? So let's start with the good. I delivered a ton of business value. I was writing code, getting stuff done, just as I said, and it was awesome. But, of course, there be dragons. Oh, there it is. There's the dragon. There be dragons, right? There's always good. You got to take the good with the bad. Got to take the bitter with the sweet. In my case, this app was fragile. Not just the Xamarin app or the Angular app, Web Forms. It was all fragile. The whole situation, the whole thing was fragile. Deployments we'd often catch problems later that we didn't know about. There was no good problem detection, right? We'd catch the problem downstream and suddenly they'd say, hey, it's been 3 days and nobody's received a text message. That's a problem, right? When your business relies mainly on texting, that's a problem. Deployments were still all manual. I was all right-click publish, which works for some people, but it worked for that organization, but it wasn't ideal because I still had to manually do deployments, and there were no quality checks, right? There was nothing building the thing to run the tests, but that didn't matter anyways because there was no testing. There was no testing done. We would do a tiny bit of regression testing. We'd test the new functionality, and off it was shipped, and we broke stuff all the time. I'm so embarrassed by this fact, I'm going to make it a little bigger. No testing. That really hurt us. So when me and my mate, Andrew, would do deployments, this is kind of what it looked like. We were like a couple of crash test dummies. We were just going to slam into the wall and see what happened. Smartly, our boss said no deployments on any day after Wednesday. So on Thursday and Friday, Saturday, we couldn't do deployments. And that was because Saturday was our main day for business. So that rule alone probably saved me quite a few weekends. So that was good. So Andrew, bless his heart, he became a junior dev too. He was following in my footsteps. He said, this development stuff is awesome. I really don't like support. I'm going to learn more about development. And so this was the structure of the company for about a year. This was a really fun time in my career. Loved this. And then one day, I was kind of itchy. I was kind of looking for a new thing. And Andrew said, hey, I just got an opportunity in my email that I think you should look at. So finally, we get to the Rivet part of the story. It's part of the rewrites, right? So this was me. I was a good engineer, I think. Like I said, I delivered lots of business value, but I just still had so much to learn. I was getting stuff done, but I was getting stuff done at a cost. A lot of people have gone through this phase in your career. I gave this talk recently, and they said, Spencer, I related totally with the get stuff done, but at a cost thing. Because, you know, at the end of the day, we're still delivering value, but we're not delivering still as much value as we could. So as much as this talk is about rewriting Rivet and talking about how it got from a project to a platform as a service, we're talking about rewriting me too. From this humble guy in college to whatever that is to the guy right on the very right side. I had to rewrite myself from being a get stuff done engineer to being a senior engineer and being an architect and on to who knows what. So again, let's talk about story time. Quick talk about what happened. This is a company called Godelnet. Godelnet fully owned the original, what Rivet originally was. And one day they got a call from one of their biggest customers and said, hey, we need to build this integration between these two software platforms. So they're like, cool, let's do it. We've got a job, right? Like, we've got a suite of developers. Let's put them to work, right? So essentially it just looked like this, like, hey, move data from system A to system B, keep them in sync. Pretty simple, right? Well, whatever they delivered worked pretty well. Everybody was happy. And so they did their little happy dance. They were very pleased until one day, this guy's my CEO, said, hey, somebody said, why don't we turn this into a product? This cannot be just an uncommon project. This cannot just be an uncommon problem. Let's prove out the market. Let's see if there's a thing for this. And that's where we get to the first rewrite, project to product. So we needed to change it to something that was built for somebody to something that was built for many buddies. And so what we did was they actually took the code that was owned by the customer, they scrapped it, and they took the lessons learned from that, and they started over. This was before my time. This was a few months before I joined the company that they did this. And this is kind of what it looked like. So SQL Server, all built on .NET framework at the time. And it kind of looked just like this when I got there. This is what they architected. The guy that architected this was a business intelligence guy, and I'm not surprised by that. Let me describe. So essentially what would happen is we would take a system, we would take two systems, we'd take that data from that system, we'd cache it in a local cache, which is a really smart idea, really great. And then we'd all centralize it into a central database, kind of like a data warehouse, right? It's almost as if the systems we build are the reflections of ourselves. This is what the guy knew, so this is what the guy built. And it worked pretty well. And then we have, if we want to connect it with a system with a REST API, we still need to be able to connect it to a system that's on premise somewhere. So we had a connector app, and the connector app basically was installed on the customer server and just did essentially SQL queries against their database on that customer's drive, and then sent it over to us. They sent it over to Rivet using a REST endpoint. And then we had what was lovingly referred to as a data process app. It would wake up, and it was installed on our servers. It would take all the data that was staged in those staging databases and mash them together, and then take any new records for one system or another and move them onto the target systems. And this was a console app, like the connector app was also the same way. They were console apps that were controlled by Windows Scheduler. Woo! It was great, I guess. It was fine. It was a good start. So essentially, it would kind of go like this. There would be a process that would take the data from the systems, upload it to our system, take the data from our local cache, put it in the central database, and then finally we'd move the data from the central database onto the system in the on-prem system. Simple, right? How many people have done integration between any kind of system? If you've integrated, yeah, of course, we've all done it. How many times is integration simple? Unless it's like a product built into an app. If you're hand coding an integration and trying to keep two systems in sync, would you describe it as simple? I wouldn't. If it's too good to be true, it probably is. It was too easy, and it didn't work very well. Let's break this down just a tiny bit. So we called this uploading, taking data from the system, moving it into a cache. We would have one table per model if it was an employee or a vendor, whatever it may be, and we'd move the data from that system into that cache. There's a lot of boilerplate involved here, whatever. Then we'd take the data from the system cache, move it onto the central database, like a data warehouse. And it was transferred via stored procedure, some duplicate detection, but limited and not very good, and also a lot of boilerplate involved in writing those transfers. And then what was called downloading. And we'd take the data from the central database and move it on to the system using their REST API or insert statements, whatever we could do to talk to that target system. Simple, right? If only, if only. So let's retrospect. Let's talk about what happened in the first rewrite. I was there at the kind of in the middle/end of it. They'd already implemented that whole system that I showed you, that whole platform. They'd already built it, and so this is what I inherited. So good. Let's start with the good. So we had early beta customers to help us develop requirements, and we were delivering value early. Our products worked, and we also, another thing that was good about this, we were proving out the market. We found that people wanted to use this integration, so now we just had the urgency to build was higher. But of course, take the good with the bad, take the bitter with the sweet. We still got to talk about the dragons. There's always dragons. One of the problems was lots of duplicates written between databases. As a person who was paranoid about data, this like kills my heart to see. We'll get back to that in a minute. The state of downloaded objects that were moved from our cache or the central database onto the target system, very hard to track, very problematic. So sometimes we'd end up duplicates downstream. And then it was hard to write and maintain object connections, moving data from the REST API all the way to our central cache. It was easy, it was boilerplate, but it was never as complicated as just move this data to here. We had to deal with things like, we were creating tables out of them, for gosh sake. So we were making property names, but that doesn't always, making properties one-to-one at the columns from the JSON, but that doesn't always work because JSON objects aren't always flat. So lots of things like that. And then deployment. Deployment was just as fun, actually way less fun than it was at my old job. At my old job, it was right-click publish. At the new job, it was this. Over and over again. How many people have had a company experience where that this is their experience during doing deployments? Yeah, a significant share of us. We know the pain here. It sucks. And then this thing, the syncing, transferring the data between stored procedures. I will come back to this, another thing. So then we get into the second rewrite. This is the part that I really was like kind of the chief of. So I came in, I was freshly hired. And my title was senior dev. I don't know who thought to give me this title, but I can tell you that I was about as far from being a senior dev as anybody else on the team. There were people on that team that were more experienced than me that were junior devs. I had no idea. I guess I interviewed well, whatever. And I jumped right in, and this is kind of what it felt like. I did add value to a lot of projects, I feel like, including Rivet. I was working on Rivet just very part-time. There was a couple of engineers. They had a process, but jumped right in and finally figured it out. This guy, Tom, our CEO, said, he was still with us then, he's still with us now, said, hey, I really would like you to work on Rivet. Let's get you introduced and get you familiar with the product. At the time, it was known as App Harmony. Not an important detail, but it took a while to get to the Rivet thing. So App Harmony. So first thing to fix. There were things that I needed to fix. Come in and say, well, senior developer Spencer, surely you know how to fix these problems, right? Okay. I can tell you I know exactly how to fix these problems, as much as I knew how to fix the problems of my previous company. I pulled them out of somewhere. You might not like it. So we had the imperfect development model. So moving the data around, very boilerplate, very error-prone. Maintenance of these things became a chore. Maintenance of data. We had constant data breakages, things that were duplicated, things that weren't showing up. The developer had to debug at every single step. Everything that had a problem, a developer had to intervene. Again, this is the state of our current architecture. Let's talk about the problems with this, right? So we had the connector app and what we called the data process app. They were Windows schedulers. Now, they were Windows scheduler built console apps that woke up and went back to sleep when they were done. Now, if we had 100 customers, what are we supposed to do? Like, oh yeah, in order to install this connector app, you have to unzip it. It's in the debug folder. You have to unzip that, and then you have to set up a Windows task. Oh my God, I'd fire them right away. So like that wasn't going to work. So they gave me a little honey-do list. They said, here's some things that we really need you to do. So we need to convert these things to always-on Windows services. We had to improve the deployment process. We had to remove obscure data bugs, which is, I could spend a day talking about that particular problem in general. And then we had to make development easier and developers more productive, right? Things weren't happening. Of course, the people on top say more, faster, and that's fine. But identify inefficiencies, make them efficient. And they were like, yeah, you got this. Okay, I guess I got this. So this was me on the left. This was me in the mirror thinking about, oh, this is my future state. This is where I want to be. I got life goals. I've got some life goals that I want to achieve. So honey-do list. Let's start from the top. Convert existing apps to always-on Windows services. Okay. First, another lesson here in my career. Reuse the stuff, all the stuff, right? Don't try to be unique. Don't try to be creative sometimes. If you need to solve the problem and go, solve the problem and go. Remember this thing, this architecture that I described? This app backend was actually built. I built a Windows service very easily using a product called Top Shelf. It's very useful if you're building Windows services still. It makes them really easy to do. And I was like, cool, I already know how to build Windows services, so I'll just install Top Shelf and off I'll go, right? And it worked. When all else fails, do what you know. Your goal is not to be perfect. Your goal is to deliver software. Your goal is to deliver value. So that's what I did. I took the knowledge that I had taken in my previous company and I just repeated it. With a honey-do list like that, like those are all full-time jobs. I had to do something, so I did what I knew. And it worked. It worked pretty well. So this was improved. This was improved because now they were always on. Not only were they always on, they were constantly, well, I'll show you. We took the connector service, we got it out of Windows Task Scheduler, made it an always-on, self-updating Windows service. Shortening that to one sentence was a lot harder than that. And we created infrastructure to receive commands for it. So that was SignalR. That was it was actually the backplane for that communication back to our home service, because we wanted to be able to push commands to it. We wanted it to push commands back to, or messages back to us. SignalR was a pretty good fit for that. And then we wanted to take the cloud service. We lovingly called it from data process to cloud service. Sounds way more impressive, especially on sales calls. Took it out of Windows Task Scheduler, made it always on Windows Service, and then we built our own scheduler. So we said, oh, we need to run this set of jobs, so we built a scheduler to actually run the set of jobs. That worked really well. And so we ended up with something that looked a little bit more like this. So we had our system cache and our central database still, and now it was talking to cloud service. A lot of that was the same. But now we had something that we could take, the connector apps, now talked home, now self-updated, so deployments were less of a problem there. Deployments internally, we'll get to that in a second. And then we had our API layer, which unfortunately, and sometimes we still live down these things, live down the technical debt we take on. The API layer was also the front end. So that was fine. This was a pretty good next step, and they were very pleased with that. I remember this guy. Well, this guy worked at my company with me, and he came on, and guess what he had just got done doing full time? Pretty much doing web forms, which you can discard, and Angular. So they were like, we need you to come in and improve the portal. He loved it. He loves doing front ends. So he came in and he made our API layer, or our management UI. He really souped it up and made it a lot nicer using Angular. So he came in, again, we're the product of our experiences, and our products are the product of our experiences, right? So we just took what he knew, Angular, and went to town. And then, of course, we decoupled the management UI and cloud service appropriately using RabbitMQ. Again, reuse the stuff you know, and it worked well. It worked pretty well. So we did that. We did this in our first rewrite, or second rewrite, we did exactly what we said that we were going to do. Convert existing apps to always-on Windows services. Done. Awesome. So, improved deployment process. Could do a whole talk just on that alone. Let me shorten it by saying we used AppVeyor. AppVeyor was a big value add for us. It did a lot of the work for us. It did a lot of great work for us, and it was awesome. So every time, if you've used AppVeyor, Azure DevOps, Jenkins, something, whatever, it's pretty much the same process. Every time we push it up to source control, build the software, run our tests, and deploy the software. It was pretty great. But we were really only part of the way there. We'd only really gotten part of our vision implemented. Like we had a whole, downstream, all the end-to-end vision, and we only implemented part of it at this time frame. We had a long way to go. Because of the way we wrote our tests, sometimes developers were writing real tests. Sometimes they were just putting ad hoc code inside of their test project, and they were just running it ad hoc in order to manually test their stuff. Okay, fine. So we didn't run the tests automatically in that, and that would have required a lot of work that at the time we just didn't know necessarily what we were doing, so it didn't do that. And then technical limitations meant that we had to deploy it all at once and stop services to do it. So we had to stop production and deploy all at once. So monolithic in that way, painful deployments. Remember this thing that I did that I was all proud about a minute ago? I did a great job. That was one of the things that suddenly made these technical limitations, that was one of the technical limitations. I'd improved it by adding on limitations. And of course, we all do this. Technical debt isn't bad, but it can be frustrating. I cannot tell you the frustration that I felt when I realized the thing that I had built, which was a little more, admittedly, at the time than we needed, the thing that I had built had actually made the second step actually quite a bit harder. But software engineering is a series of trade-offs. There's never a silver bullet, right? My goal was to do this, so I did this. This is the first thing I needed to do. And then I needed to improve the deployment process. I didn't say make it perfect, I said improve. And of course, getting to what software development should be ideally is iterative, agile, right? That's the true definition of agile. Do little things at once at a time, build up your software. So even though we'd improved the first thing, we'd improved the second thing, I made some choices, right? That made the second thing a lot harder. But that's okay, because our job was to improve and we got our job done. So AppFair, huge value add for us at the time. We're now moving to Azure DevOps because their tooling is just way better, but that's another show. Oh, this was a big one. Remove the obscure data bugs and make development easier and developers more productive. Whew, all right, well, see what we can do. So our main goal at this point was we were moving data between a cache database to our central database. So we did so this is what we did as part of our development process. Let's take Salesforce and QuickBooks, for example, just picking on them. We would have maybe a customer in a Salesforce app and a QuickBooks customer, for a QuickBooks app, and we'd create separate databases for those things, and we'd cache the data there, and we'd also model the data as it were. We tried to do basically a copy paste, right? We didn't want to be special and rename things. We just wanted to take it as it was from the source system and cache it locally. So we do things like we'd have customer name, because a lot of people, when they, a lot of times when you're building APIs or whatever, sometimes the thing was a customer object and the JSON you'd get back was still customer name. All right, that's fine. So we'll call it customer name. And then we had the create date. And then, of course, we had QuickBooks where they didn't have a create date, just making this up as I go, bear with me, but they had an open date, which was kind of the same thing, kind of wasn't, whatever. So they had similarities, right? They're never a perfect fit, but they're pretty close, right? In business, they're essentially the same thing. So the first thing we did to move data between them, this was before my time, they used SQL Server integration services. Apparently, we never talked about it. I never asked why, because developers would curl up into a ball and cry when I asked them, why did you move away from it? So I just kind of dropped that. I don't know why they moved away from this. Apparently, it wasn't good. So that's fine. So then we were doing entity framework. They were spinning through. They were just for each QuickBooks customer. Is it in the Salesforce staging database? No? Okay, then create a new record. Else, update the existing record or whatever, or delete it if you need to. But this was really slow. It was slow as in that it took a lot of time in order to process all of that data. So they discarded it because they wanted to move fast. They moved to stored procedures. Stored procedures. Now, developer, I don't know about you, but I still suck at writing SQL. Remember the Sonic picture. And developers, for some reason, at our organization just had a hard time writing stored procedures. They looked something like this, right? And they would have special logic, like if it exists, left join on the target table, and if the thing didn't exist, put it in there or update it, right? But SQL is not a very friendly language, as friendly as a strongly typed language like C# or VB.NET. Because as soon as you do this, you have to do this for hundreds of objects and thousands of properties, right? This is thousands of properties downstream as you took every object that you needed to move. And by the way, don't ever make a mistake. Now, up to this point, we'd had data wasn't going in. Data was going in too much. It was duplicating, right? So these were loaded with bugs. They just were. So what did they do? They called in the senior dev. This was what I wrote in on. This is what I actually was, right? Just a dog at a wheel, right? So I was just like, oh, okay. So I turned to my boss one day and I said, hey, I understand the source of the pain here. I think we can build something to effectively describe how to move these objects around. And he said, okay, what do you have in mind? And I said, I know about these things called expressions, right? And he said, okay, build me a prototype. You have 1 hour. What? Okay. In 40 minutes, I'd come back with roughly something where I was like, okay, Here's the objects, here's the expressions that I use, and I can bind them together using something like this. So I created I would create this definition class, essentially, and we'd use it to describe, like, okay, the customer name trimmed, because working with even legacy systems or sometimes newer ones, sometimes they love to pad spaces on the beginning or end, and I still haven't figured out why they do that, but it's not desirable to see that in target systems, so we want to trim them. And then we want to say, well, that's the QuickBooks. Take that trimmed customer name and put it in the QuickBooks name. And then take that create date. Oh, by the way, open date is actually a required field, so we need that. So take a create date if one's not available because it's nullable in the from Salesforce. Put in the current date and time and put that into the open date. And so what we ended up with is creating these strongly typed definitions to move data around. So it generated SQL that looked a little bit like this, right? So we take the insert statement and it would emit really nice looking SQL, kind of like how TypeScript, pushes out some JavaScript at the end that actually reads pretty well. That's what we would emit, and it worked pretty well. So this, because we knew that because it was an expression, because we were calling trim, we know that we are going ltrim, rtrim on customer name. Typo there, should say customer name. But that's what it would emit for SQL. And then for create date, going to date time now, of course, the null coalescing operator translates roughly to the is null in SQL. So we'd say create date. If not, we know to use the get date function in SQL to move the data around. So this is essentially what we were doing. And remember that thing that I said about paranoia? I have to thank my old boss for drilling in this data paranoia inside of me, because it served me really well. I was so against bad data. I was like, we are done with duplicate data problems. We are done with moving data, data not moving. But I really attacked the duplicate data problems. So under the hood, with these definitions, I was able to add logic to run this statement, make sure that the data moved all up appropriately, make sure that there was no duplication. If there was a duplication, stop the transaction, otherwise commit. And suddenly many of our data problems went away. And it was awesome. What this did was made developers way more productive and they were writing out less buggy code. It wasn't perfect, but they weren't writing stored procedures. And suddenly now we had a lot of data protection, and the developers were making data move even better. It was awesome. So what fit? What didn't? Let's talk about it. So we vastly improved our platform. We vastly improved our deployment story because we needed to scale, right? We wanted to get to multiple customers using this product. So we had to do some things, and this is what we had to do, right? We had to make the connector app more deployable, et cetera, et cetera. So we made that. We vastly improved our platform and deployment. It was great. Deployments were still painful. They were still painful, but they were better. So we'll take that, right? Software should be iterative, right? So the development model was improved. It still wasn't perfect, and we'll talk about why in a little bit. And this is a lesson. This is something that I believe strongly in my heart. Premature optimization is the root of all evil. I didn't prematurely optimize. I am a developer, and somebody told me once developers who are straight, developers that are just C#, VB.NET, that's what they know well. They don't write SQL very well. I don't know if that's true for you. It's certainly true for me, because these statements ended up being a scale problem because they were slow and they were emitting SQL that wasn't ideal. So without the help of a DBA to turn red and get angry and throw things at you to make you work better, to make you write SQL better, we were moving data, but we weren't moving it the most efficient way. So we had some problems with this as we grew. So this was it. This was the architecture we ended up with. And a lot of time passed. There was a lot of things that happened. I'm going to skip a lot because we're getting to the meat, right? A lot of changes happened. Some of the changes were good. Some of the changes were bad. Some of the changes felt like this. We had customers that we would churn customers, we would churn partners. Sometimes we would build an integration, it wouldn't work out. Sometimes we'd build an integration, it would work out really well. So we were doing a lot of things. We were experimenting, and it worked pretty well, but sometimes it was painful, right? But whatever, we were still delivering value. You can't criticize me because I tried, right? So, of course, that's never how it works. And that's when GoodellNet also spun it off into Rivet. And at that time, at some point, I started my own software consultancy and said to my company, hey, you can be my first consultant or my first client. And they didn't really have much of a choice because I built all the other underlying systems. What are you going to do? That worked pretty well for a while. I eventually spun this down and joined them again, which was a great move, and I'm very happy with that. And other lesson learned, the central database. This data warehousing model, this very data warehousing-esque model didn't work too well, right? And the reason it didn't work too well is that a customer in one system, a customer in another system, we were trying to boil it down to one thing. And if there's one thing about software that I said earlier, one size does not fit all. What ended up happening was the central database ended up being a lowest common denominator for lots of things. So we threw it out. And that was a really good choice at the time. Talking a little bit about the SQL, right? I made stored procedures to these tight little definitions that emitted SQL, worked really well for that model. But in the end, it didn't work too well just from a business perspective because it was set-based. It wasn't object-based, like individual record-based. It was set-based. We were moving sets of data because we were emitting SQL, right? So the performance was pretty good. We optimized, got pretty good performance out of it. And we had a straightforward development pattern. Great. That was great. We loved these things. We loved them for a time. But they poorly represented the nuances of business workflows. Moving data to data just wasn't, that's not how business works, right? If you approve an invoice in one system, you really need to tell the other system that you approved the invoice and then trigger some kind of workflow, right? And our set-based data model, just moving an object to an object, didn't work so hot for that. It wasn't fast enough. We had to run every service in a certain sequence, and it took sometimes an hour, sometimes 30 minutes, sometimes 10. It really depended on a lot of things, volume of data, etc. Lots of customers were happy with it. Construction is the #2 industry, but so far behind from a technology perspective. That's what our goal is to improve that. So a lot of them were just happy that we moved data around, but some of them, they get a taste of that poisonous apple. They want a little more. They start wanting real time. Development straightforward, a little cumbersome, right? It was better, but it still was basically an abstraction on top of SQL. Had some difficulties with it, so it wasn't perfect. And like I said, real time. They wanted it right now. Some people wanted that data to move this thing to this thing. So we had to build it. So again, retrospecting. What happened? What worked well? What didn't? Well, let's start with the good. Just because we had this old model of the central database and we were like, we could have just continued to invest in it and continued to, use the sunk cost fallacy. We've already spent this much money on it. We just need to keep spending because we don't want to feel like it was a waste of money. We didn't stick with it just because. We ended up throwing it out. That was a good decision. And we had lots of happy customers. Some that weren't, totally happy. There were still problems with what we were doing, but we were making them happy. So we had customers, we were growing. That was awesome. But with the bitter comes the sweet, right? We needed it to be faster. We needed it to be more customizable. We needed exception handling, better data exception handling. SQL, sets of data through SQL, really poor way of dealing with nuance and exceptions in data integration. It just is. And developers built the platform. They were still responsible for putting out most of the fires. Just a thing. So at this point in my career, I was kind of right here. I was kind of like in this phase, in the senior dev to architect role, right? I was having to think not only as a senior dev, but starting to think more like an architect. And we'll see that in a second. What fit and what didn't as I was rewriting myself, right? First thing, be a multiplier. As the best thing that you can do as a senior developer or a leader, either you have developers answering to you or you're a team lead, whatever the case may be. If you're a senior developer, multiplying yourself doing work to multiply your developers should be your #1 priority. And I learned that you should scale people before you scale software. If you make them better, they'll make everything better, right? It was awesome. This was a good example of scaling. I made them more productive by taking away a lot of pain points out of the development process, and that worked really well. There were other ways. I'd have regular meetings with them, right? We built developer tools, right? So we built the developer tools like the SQL emitting little bots, perfect. We established patterns of reuse. That was a really strong one, right? I was just saying, here's the pattern, implement the pattern, test the pattern like this, and you'll be successful. And that worked really well. I give a talk that I tweeted out a bunch of links to a bunch of stuff that I referred to in the slide. This talk is all about making a pattern for your company and making a specific pattern for building APIs for ASP.NET Core. And really cool story. Somebody came up to me at a conference that I went to, and they said, "Hey, Spencer, you gave a talk here a year ago on this thing." And he said, I turned around and I implemented that pattern at my company. And all of our company, 50 plus developers, use this pattern now. And it was really helped us a lot. So if it can help him and it helped me, it can certainly help you. Patterns of reuse. Consistently okay is better than being inconsistently good. It would be like, it's better to stick with the established pattern if it's good enough for that moment and it's not causing you huge pain. Better to do that than to be inconsistently better. Like just because you have a project with 500 React components, you want to move to React hooks because it's the new hotness. Well, there's problems with that, right? You still have to tell your other developers about it. Do you have to refactor your old code, right? So it's better to be, I found, consistently okay, better than inconsistently good. With people, it's important to compliment them and complement their strengths. Figure out what their strengths are and give them problems to help you figure those problems out, to help them help you figure them out. And then gently help them recognize and compensate for their weaknesses, right? Know what they're good at, know what they're not good at. Know what you're good at and not good at. Really important things. Regular one-on-ones helped a lot. I'd sit down and say, let's pair program. There's a company in St. Louis, Missouri, that's where I'm from, the United States. They do all pair programming. We found that doesn't work for us. So we do occasional pair programming. We found that works really well. And I'd sit and pair with a junior. Sometimes I'd learn from them. Sometimes they learn from me. In the end, we all came out better. And embrace imperfect code, especially if it's backed by tests. This is kind of a thing that I like. If it's stupid and it works, might not be so stupid. I tweeted out once that I'll take bad code backed by good tests over good code any day. And my friend Eric, who's an architect as well, said, well, this is an interesting philosophical question. If the tests are good, how bad can the code really be? You have to think about that one. And finally, for the second rewrite, if you're not embarrassed by the first version of your product you've launched too late. This is the guy, Reid Hoffman, who founded LinkedIn. And we took this and we really embraced it. We were not totally happy with our product, but we had customers. We had money coming in. And that has made all the difference. So the third rewrite. So we started it in really the end of 2017, 2018, middle of 2018, full force, and we're still working on it today. When will it end? We'll let you know, right? We really took down and we said, okay, we know what we're good at. We know the problems. We know the pain points. Let's focus on making those better and try not to compromise anything else in the process. Not always possible, right? But still good. So at this point, this was our architecture at that time. We had pretty much the same thing as I described before, but we added in a customer UI and we did React with that one. So we took a lot of this stuff and we said, okay, well, there's still things that we could do to improve it. Again, poorly representing the business workflows, that's set-based data moving. It didn't work out too well for us. We had to scrap it. It wasn't fast enough for our customers, certainly not customizable enough for our customers, and the development was straightforward, still a little cumbersome, right? Because it was still a lot of boilerplate. We had to new up a SQL database. We had to create models in Entity Framework with those exact things. There's a lot of boilerplate, and we found out that, especially when you do custom fields, that becomes really painful. So we started embracing schemaless. We started embracing schemaless databases, and we started with Cosmos DB as the first thing that we did, right? The cool thing about Cosmos is that it's really easy to create a data structure that is dynamic, right? So we had a consistent data structure that contained all the metadata that we need, and then we can put as much data as we want into it. It really simplified our development process, just getting the data cache, because we found that the data cache, again, huge benefit. Our application became as we designed it from the ground up to be more decoupled. With the old application, we had to deploy everything at once. Kind of like the crash test dummies that I was showing you earlier. We still live some of that pain today, right? So we wanted to decouple. So we used Azure Services, Azure Service Bus specifically, to start moving individual data records around, as opposed to, and really signaling that those data records had come in, as opposed to just moving it set by set. We really embraced record-based processing. This is kind of how it works today. It's very simple. We wanted to keep it simple because simplicity means it's easy to understand, and it has covered pretty much all of our use cases for so far, right? So a new record is added or changed in the Rivet network or deleted. We trigger something for that record. Some process is listening for that record to change. If it changes, bam, it triggers another process to trigger a workflow to move that data around, right? And we can do a lot of cool things with this. We can do if a status of an invoice in one system has went from open to approved, now we can say, oh, let's create a custom approved record. Now we'll signal to any integration that wants to listen for it. We'll say that this invoice was approved. A system downstream will say, awesome, got it. Now I can approve the invoice in my system and keep everything in sync. So again, going back and embracing that pub sub model really worked out for us. And this is kind of what we've ended up with. So we've ended up with a really cloud-backed. Notice that we tried not to reinvent the wheel as much as we could, right? You can't beat them, join them, and you certainly can't beat Azure, AWS, those kinds of services that are providing really solid. Cosmos DB, the service bus, they provide really solid services, and it took away management of infrastructure, which we are not so good at. And this is what we've ended up with. We've embraced React and .NET Core as our go-to standards. And in this way, we've really built out a platform to allow people to build services on top of our system. And in that way, that's how we went from being a software as a service, where we just said, here's the integration data, to a platform as a service. We have this integration data component, but with this integration component that we can build for you, or you can build it yourself. We are building the tooling to enable people to do that. And finally, well tested. Oh my gosh. We came up with for all of our main core services. We had suites, hundreds of unit and integration tests. They run every time we build. Every time we build in Azure DevOps, it's running all of those tests. It takes a little while, but at the end of the day, I can sleep on Fridays. I can sleep in on Saturday, knowing that it's well tested and it's going to be and that if we happen to catch the random thing that isn't covered by a test that's a bug, great. We'll write tests for it to cover it. We can go back to sleep. It's perfect. Lessons learned from this rewrite. Don't forget your roots, right? Couple of things to talk about here. The business is more important than the technology. And what I mean by that is that the business is knowing that people came to us to solve their business problems, right? The technology didn't matter to them. They just wanted to see the data move appropriately, and they wanted to see their customers happy, or they wanted to be a happy customer. And so we were able to do that. We embraced technology as much as we needed to, but we never forgot that we are mainly in the business of solving integration problems for the construction vertical. That's always served us well. This was roughly our current architecture from we still had customers on it, right? This third rewrite, we have customers on it, but we still have lots of customers on this, and we can't forget about them. New may be cool and shiny, but legacy still matters, because that's still where a large part of our money is coming in. That's fine. We take it for what it is, learn the lessons. We're working on a transition plan. It's never easy, but we're working on it. So, getting down to the nitty-gritty, what worked and what didn't? I'm not going to bash monoliths. I'm not one of those people that says you have to break everything out into microservices. If I went to my first company and said, hey, you really need to break everything out into microservices, they'd probably look at me with a blank stare like, well, why? And I wouldn't be able to come up with a good answer. The monolith model for our old product worked until it didn't. And then we improved it, and we've made it a lot better. So just know it's hard. It can be hard to recognize when that shift needs to occur, but it's really valuable. But I'm not here to throw the baby out with the bathwater. Monoliths are sometimes good. Just depends on the business you're in and what you're building. So the early wins are really promising. It's a very easy and very testable development model. Very much easier to support, especially from a data perspective. Developers no longer need to be the first person to look at the data to see if it's broken. It's much faster, and it's much easily customizable. There's a lot of early wins that we've found as far as addressing old pain points. We've moved forward a lot. We're still finding those dragons. We're still finding those bugs. Guarantee it. To ask me next year when I'm here next year, ask me what they are. Going back to the rewrites, not only we've achieved that. We're still in the process of doing it, but we have really, truly taken something, rewritten it 3 times, and we're making it even better. And we're going to scale even better as a result. And as for me, well, this is where I left off, right, last time. And I can't do it all, right? And you can't do it forever. You certainly can't do it all forever, because change is inevitable. As your company grows, you will need to grow too. I read an article by this guy. I tweeted it out. I highly recommend taking it a read. This guy's name's Steve Blank. And he said that he worked at a company where he was the VP of marketing, and he was at the top of his game until the new CEO came in and he said, "You're awesome, you've done an awesome job, but I'm gonna fire you because you're the wrong person to take the company to the next step." And I gotta tell you, that article triggered, I sent it immediately to my CEO. It triggered every one of my insecurities. It's like, I hope this doesn't become me. And he's like, dude, brother, I hope it doesn't become me either. So really learn to recognize as your company grows, as your company changes, how will you change yourself, or will you change yourself? Is it better for you to walk away? Only you can know that. Read the article, really highly recommend it. As for this, I was here, sometimes I'm here, and sometimes when I need to get nitty gritty, sometimes you just need to get stuff done. Everybody makes those sacrifices sometimes. So where am I at the point of the rewrite? As far as myself, I don't know. I'm still working on it. I like to think I'm here, but it's never that simple. Oh, one last thing before I go. I'm sure they've announced the day. They will announce at some point the dates for NDC Oslo next year. I'm hoping not to be on the schedule with this talk. 7 rewrites, one startup, because I'll probably be out on the streets of Oslo or somewhere begging for money, because I'd certainly be out of a job. That's it. That's all I have for you. If you have questions, please come see me up front. I'm here all the time. I'm here the rest of the conference. Find me on Twitter if you're not able to come up. Enjoy the rest of your evening. Got a boat cruise to catch. Thank you very much.